and looked again carefully. And what you can see inside these channels are smaller networks created by smaller incisions of water flow. And this helps us to constrain how quickly they formed. These are quite common inside these giant valleys if we're able to resolve them in enough detail. So to then scale this up to a larger ice sheet, we turn to a reconstruction of a model of the last ice sheet to cover the UK and Western Europe. So this image here shows how ice grew and then retreated over the UK and the North Sea between 30,000 years ago and 15,000 years ago. The blue is the ice here, and the redder areas are flowing faster. We then took our model and worked out how the water was flowing underneath that ice. If we zoom into an area over Denmark in more detail, we can see how all the water is going from the surface of this ice sheet through the ice to the ice underneath it, flowing, causing these giant channels to form. And the headline number we found out of our model simulations are that it just takes thousands to even hundreds of years for these giant channels to form beneath rapidly melting ice. That might sound like a long time, but very substantial versions of these channels can grow within just decades, potentially causing these rapid fluctuations in ice behavior over just human timescales we might see in the future. Now, these channels are not only important for understanding and improving ice sheet models, but they also have implications for achieving a net zero world and addressing some of the most important issues of our time. So the landforms we found inside these channel valleys under the North Sea seafloor actually contain lots of shallow gas. So in this image on the left here, you can see areas of red showing pockets of gas flowing through these features. And these have quite important implications for achieving net zero. The first of these is that if you want to install renewable infrastructure close to the seabed or formerly ice-covered environments, you need to consider these valleys, particularly if they consider or contain smaller landforms within them. This is because if you want to install your wind farms, they could potentially explode as you drill the footings into these gas-filled features. Another implication is that if we are turning towards capturing CO2 and storing it in the old, disused oil and gas fields, which is a growing technique, still fairly early on, but will probably be needed to achieve net zero in the future, particularly if we continue on our current policies. The fact that these valleys are so widespread and contain these very porous flow features within them means that if you're trying to pump CO2 back into these disused oil and gas fields, this could then flow through the substrate, up through faults into these features, where they'll be released, potentially escaping the CO2 back into the atmosphere again. So what we can learn from a study of past ice sheets and why they're relevant for the future is that understanding the past is really key to predicting the future of ice sheets. Water clearly affects how ice sheets flow and will be increasingly important as the climate warms in the future. These ancient tunnel valleys are essentially the plumbing systems of ice sheets in a warmer world. The water can form them quite rapidly within just hundreds of years. They can both stabilize and destabilize ice sheets in a warming world. Perfect. And they're also incredibly relevant for how we're going to achieve net zero through installing renewable energy infrastructure and also trying to capture some of the CO2 from the air and store it back underground again. So I'm going to go back to this image again to finish showing the tipping points that we're approaching in this world. We know from the past the cryosphere can exhibit very large and very rapid changes that are not necessarily captured by our modern era of observations. These sorts of changes will be devastating for modern society. Every 1/10 of a degree of warming that we can prevent means that these changes are less likely to occur. This also means that we have more time to respond and adapt to the changes that we are already committed to. But we have to act now. The policies made here at COP27 are crucial for maintaining an environment which is going to affect billions of people around the world. Let's make these choices the right ones. Thank you for listening. I'll be happy to answer any questions you might have. Any questions?
So with the seismic analysis, how far back in time can you go right now where you're focusing?
That's a great question. So in the North Sea, it's basically a big bowl which sediment has been brought in over millions of years. And so we can see all the way back through the Quaternary period, which is the period, the most recent geological epoch, going back to about 2.7 million years ago. But there are sediments which are much, much older than that too. So it's really a fantastic technique to go back in time and use these ancient periods as analogues for how our climate might look in the next few hundred years in the future. Any further questions? Perfect. That then concludes. We have one more question.
Sorry, though we came in very late. And can we have the soft copy of the presentation, please?
So can you repeat the question?
Can we have the soft copy?
A soft copy of the presentation?
Yes.
Yes, I can give you my email address and we can share that with you. Absolutely. Any further questions? If not, this will conclude our test event and we'll be up with the IPCC presentations shortly. Thank you very much.
Bradley.